Imagine a world where almost everyone lives alone, in small underground rooms. They rarely leave. They summon food and entertainment with buttons. And when they meet, it's through a glowing blue plate that shows a face.
It sounds like a critique of modern screen life, but it wasn't written recently. It first appeared in November 1909.
Wait, 1909? That is before the First World War.
It is. The story is called The Machine Stops by E.M. Forster, published in the Oxford and Cambridge Review. It doesn't predict the internet in a technical sense, but it's uncannily close to always-on, screen-mediated communication and the isolation that can come with it.
Did he actually describe a screen, though, or is that just us reading into vague old words?
It's explicit. Vashti touches the isolation knob, and then a round plate in her hands begins to glow, a faint blue light, until she can see the image of her son on the other side of the world. Forster even calls it a blue plate.
So he basically invented Do Not Disturb mode a century early.
Pretty much. At least the idea of isolating yourself from interruptions. But the real prediction is the social one. Later, when someone reaches out to steady her, Forster writes, "People never touched one another." And Kuno's line still lands, "I want to see you not through the machine."
That is creepy accurate. But that is just the start. If you think a 1909 iPad is weird, wait until you hear about a fictional shipwreck written in 1898, 14 years before the Titanic sank in 1912.
Let's go back to late January 1926, the Roaring Twenties. Nikola Tesla gives an interview to Collier's, and he drops a prediction that sounds impossible for the time.
What exactly did he say?
He described a future instrument. He said, quote, "A man will be able to carry one in his vest pocket."
Okay, a pocket radio. That doesn't sound too wild. Radio was already a thing, right?
Not like this. He wasn't just talking about listening. He said we'd communicate instantly, irrespective of distance. And here is the kicker. He said we would see and hear one another as perfectly as though we were face to face.
Wait, he predicted video calls in 1926?
In spirit, yes. He even framed it as television and telephony working together. And the timing is wild. On January 26, 1926, John Logie Baird publicly demonstrated recognizable television images in London. Tesla's Collier's interview ran just days later.
That is eerily specific. Did he get anything else right in that interview?
He went further. He said we'd be able to witness events like a presidential inauguration or a World Series game remotely, as though we were present. That's basically live broadcast, what we'd now experience as live TV, and often as streaming.
Okay, I'm impressed. But was this just a lucky guess? You know, throw enough sci-fi ideas at the wall and something eventually sticks.
Perhaps. But the big idea was the network. He described the whole Earth becoming a huge brain, a world where the device matters less than the connected system behind it.
So, did he actually build it, or just talk about it?
He didn't build it. He didn't have transistors, microelectronics, or modern wireless networks. But he sketched the destination with eerie clarity, long before the infrastructure existed.
Spooky. But he wasn't the only one seeing the future of disaster, was he?
Not at all. Let's talk about a ship called the Titan.
Picture this. A massive luxury ocean liner sets sail across the North Atlantic. It is the largest craft afloat and the greatest of the works of men. The public calls it unsinkable. Then, on a freezing April night, it strikes an iceberg on its starboard side and sinks.
It sounds like history class, but you are actually describing the plot of a novella called Futility. It was written by Morgan Robertson and first published in 1898, then revised and reissued in 1912 under a longer title.
Wait, 1898? That is 14 years before the Titanic struck the iceberg on April 14, 1912.
14 years. And the fictional ship wasn't called the Titanic. It was called the Titan.
Okay, that is getting weird. Just a lucky guess on the name?
It goes way beyond the name. In the text, the Titan is described as practically unsinkable, about 800 feet long, and capable of 25 knots on trials. The real Titanic was longer, about 882 feet, and her service speed was lower, around 21 knots, with a top speed in the low 20s. And yes, both stories hinge on an April iceberg collision in the North Atlantic.
That is terrifyingly specific. But the real tragedy of the Titanic wasn't just the ice, it was the lack of lifeboats. Did the book get that right?
Uncomfortably close. Robertson writes that the Titan carried as few boats as would satisfy the laws, 24 lifeboats total, holding only about 500 people, on a ship with roughly 3,000 berths.
And the reality?
The real Titanic carried 20 lifeboats. Their total capacity was about 1,178, barely enough for roughly half of the people on board.
So, coincidence or curse? Was this guy a psychic?
Not a psychic. Robertson had spent years at sea in the merchant service. He was watching ships get bigger and faster, and he understood how slowly safety rules and habits were changing.
So he didn't see the future, he just saw the bottleneck.
Exactly. He extrapolated the complacency of his era to a logical endpoint. When confidence and scale outpace safety practices, a catastrophe becomes more likely. Let's go back to 1865. The American Civil War has just ended. Electric light is still more lab demo than household staple. And Jules Verne publishes From the Earth to the Moon.
I know this one. They shoot a bullet at the moon. But come on, writers guess things all the time. Did he actually get anything right besides the general idea of going up?
He got some headline logistics eerily close. Start with the launch site. In the book, the gun club narrows it down to Texas versus Florida and settles on a spot called Stones Hill near Tampa Town, Florida.
Florida, okay. That is close to Cape Canaveral. Was that just a lucky coin flip between two southern states?
Not a coin flip. In the story, the why is astronomy. They argue the cannon has to fire toward the zenith, and Verne points out the moon only passes directly overhead within about 28 degrees of the equator. So the U.S. options collapse to the far south, basically Florida or Texas.
So he did the homework.
He did. And a century later, NASA also chose Florida for a real moon mission. For geography, for safety over open ocean, and because lower latitudes help for launches. But the similarities get spookier. Verne's projectile carried a crew of 3.
3, just like Armstrong, Collins, and Aldrin.
Exactly. He even named them: Barbicane, Nickel, and Michel Ardan. And finally, the return. In the sequel, Around the Moon, they splash down at sea and get recovered by a U.S. Navy ship.
Okay, the Navy recovery part is impressive. Most sci-fi back then probably had them landing in a field or a city. Did he say the Pacific Ocean specifically?
Yes, the story places the recovery in the Pacific. Some printings even disagree on the longitude in the telegram, but the method, a capsule splashdown recovered by a warship, was the bullseye.
So, was he a time traveler? Or did he get anything wrong?
He missed the propulsion. Badly. Verne used a giant cannon called the Columbiad.
Right, being shot out of a cannon.
It would have subjected the crew to catastrophic acceleration. Physics says no. But structurally? A Florida site, 3 crew, an aluminum projectile, ocean recovery. That's a lot of the mission profile. 104 years before Apollo 11 flew.
That is wild. It's like he wrote the script for NASA.
In a way, he did. And with a major new annotated edition scheduled for June 30th, 2026, people are still digging into just how carefully he extrapolated from the science of his day.
Okay, we've covered the ocean floor and a trip to the moon. But what about the invisible infrastructure orbiting in between?
For that, we have to look at Arthur C. Clarke. Most people know him as the sci-fi legend behind 2001: A Space Odyssey. But in 1945, he was working as a radar specialist in the Royal Air Force. And he had a very practical idea.
1945? That is 12 years before Sputnik. We didn't even have rockets that could put something into orbit yet.
That didn't stop him from doing the math. In October 1945, he published an article in Wireless World titled Extraterrestrial Relays. He proposed that if you launch a satellite high enough, about 22,000 miles or roughly 36,000 kilometers above Earth, something weird happens.
Magic? Or physics?
Physics that feels like magic. At that altitude, the satellite's orbit matches Earth's rotation. One sidereal day, about 23 hours and 56 minutes. So from the ground, it appears to hover over the same spot.
So it's like a cell tower that never moves, but it's in space.
Exactly. Clarke argued that 3 of these stations, spaced 120 degrees apart, could provide near-global radio coverage, with the main limitation being high latitude and polar regions. He sketched the core idea of satellite communications decades before we could build it.
That sounds incredibly valuable. If he invented the architecture for modern comms, he must have been the richest man on Earth. Did he patent it?
He did not. When people asked him why he left billions on the table, he gave a famous response. A patent is really a license to be sued.
Ouch. Fair point. So, did reality match the drawing?
It took about 20 years. In 1964, SYNCOM-3 became the first geostationary communications satellite, helping relay broadcasts from the Tokyo Olympics to the United States. Today, that orbit is often nicknamed the Clarke Belt, and it's crowded with communications and weather satellites.
And I assume that's where my GPS comes from, too.
Actually, no. That's a common misconception.
Really? I thought all the useful stuff was out there.
GPS satellites fly lower, in medium Earth orbit, about 20,200 kilometers up, and they're not fixed over one point. Your receiver figures out where you are by timing signals from multiple satellites as they move across the sky. Clarke's vision was specifically the high-altitude, fixed-position relays that connect the world.
Still, predicting modern satellite communications in 1945 is terrifyingly good.
It is. And speaking of the internet, our final visionary didn't predict the hardware, he predicted what it would do to our minds. Our final stop is December 1999. The dot-com bubble is swelling, and on BBC Two's Newsnight, the legendary musician David Bowie is sitting across from the famously skeptical Jeremy Paxman. Paxman tries to ground the hype. He asks, "It's just a tool though, isn't it?"
I've seen that clip. Paxman looks at him like he's crazy. He's basically like, so what? It's just a new delivery system.
Exactly. But Bowie pushes back hard. He tells Paxman, no, it's an alien life form. He wasn't talking about little green men. He was saying the internet would demystify the wall between the artist and the audience, and that culture would splinter into total fragmentation, countless subcultures instead of one shared monoculture.
Okay, alien life form is a great soundbite. But did he actually know what he was talking about? Or was he just being poetic?
He'd actually been building in that direction. In September 1998, he launched BowieNet, an artist-branded dial-up internet service and member site built with partners. And back in September 1996, he debuted Telling Lies online first, often credited as the first downloadable single by a major artist.
Wait, an ISP? Like, you would pay David Bowie a monthly fee to get dial-up?
You would. And subscribers got an @davidbowie.com email address, chat rooms, forums, and exclusive content. Basically, a members-only online community years before the modern social media era. But here's the key prediction part. In that interview, Bowie said the interplay between user and provider would get so tight it would crush our ideas of what mediums are all about.
That sounds like the creator economy. TikTok, YouTube, comment sections. The audience is part of the content now.
Precisely. He saw the internet wasn't just the library, it was a feedback loop. In early 1999, only about 41% of Americans were even online. Napster had only just launched that summer. Yet Bowie could already see the pedestal cracking. Creators and audiences were about to collide in public.
So Paxman saw a tool, and Bowie saw an ecosystem.
And history sided with the alien life form. The old idea of a single, shared monoculture is much weaker now. Attention splinters into niches, feeds, and algorithm-shaped bubbles, just as he warned.
So, be honest with me. Is the secret ingredient time travel, or just really good guessing? Because getting the iPad, the moon landing, and the psychology of the internet right seems impossible.
It's not magic. It's math. Specifically, it's the difference between linear thinking and exponential thinking. Most of us picture the future as today plus a
slow and steady.
Exactly. But a lot of technology doesn't move like that. It compounds. Think about Moore's Law. In 1971, the Intel 4004 had about 2,300 transistors. By 2021, leading chips were in the tens of billions. Apple's M1 Max was around 57 billion.
57 billion. That is a lot of zeros.
That's the curve. Tesla didn't need a crystal ball to imagine a pocket-sized communicator. In 1926, he described vest pocket wireless telephony. He saw the bottleneck shrinking away.
Okay, that explains the gadgets. But what about the social stuff? Forster predicting isolation, Bowie saying the internet would become an alien life form.
That's the second piece of the puzzle, network effects. A single fax machine is a doorstop. 1 million fax machines is a revolution. And in that 1999 interview, Bowie was pointing at the same thing. Once everyone's connected, culture itself changes.
It stops being a tool and starts being an environment.
Precisely. In 2025, the ITU estimated about 6 billion people were online. That's not just a market. That is a global nervous system.
So, for everyone watching who wants to predict 2050, what is the lesson?
Stop staring at what exists today. Look for what keeps getting cheaper. Look for what keeps doubling in capability. Then ask, when this becomes effortless and everywhere, what breaks and what gets rebuilt?
What breaks and what gets rebuilt? I love that. If you think you've spotted the next curve, let us know in the comments. We might be reading your prediction in 50 years. Thanks for watching.